Okay, we're back on the air. Here we go. So, remember from last time, we didn't get to record. Your name, clear home, prompt for A, B, and C from a quadratic equation, ax squared plus bx plus c equals 0. Solve for the discriminant and use it to figure out one of the roots. So, did we finish testing this? I think we didn't. Let's try it, okay? Clear. By the way, program, edit 4. Everyone has this, right? Who's stuck? QUAD1? All right, so let's test this. Let's do the real irrational unequal case. I think what it is, what was that? I think that was 2, 1, 0, negative 1. Okay, so 1, enter, 2, enter, negative 1, enter. And when you get wacky decimals like that, that's irrational, right? Now, we only have one root, but if we had both roots, you would see that they were real, irrational, unequal. Did anyone not get 0.414 something? Yes, 1, 2, negative 1.
I got 0.414.
Good, that's it. Who else? Anyone else not get it? All right, so try it again. Hit enter to run it again. Now if I do 1, 2, 0, we should get real rational equal, no wacky decimals. One root is 0, that's correct. Did you get 0 for that one? Okay, now we have to fix this. What's missing? What's missing? Root 2. We'll get to that in a second. All right, let's test let's test this one. Whoops. 1, 2, 1 was real rational equal. I think the roots are negative 1. Did you get negative 1 for 1, 2, 1? Yes. All right, now here's the problem, though. What about this one? 1, 2, 2, I think was complex, right? What happened? Did you get that? No? You should have got that. 1, 2, 2. 1, 2, 2 gives you a non-real result. We're going to handle that. Yep. Who didn't get a non-real result? That is the right wrong answer right now.
Mine has
It doesn't know how to square root a negative. D is negative there. All right, there's the code. You did? Okay. Good. Well, yeah, but you're in the display. All right. Who else is stuck? Anyone stuck? No, yes, I think so. All right, anyone stuck? Yeah? These are all freezing lately. Yes, sir. I can't fix these things now. I'm done fixing these. Okay, so the problem is when D is negative, 1, 2, 2 gives you a negative 8, I think it is, for the discriminant. You're going to get I's, and the problem is that your mode has to allow for that. Now look at my mode. My mode is set to round off to 4 places. That's not an issue here. Use degrees when you're doing trig. We're not doing trig. Graph in polar mode. We're not graphing. Do connected graphs. We're not graphing. Do sequential graphs. We're not graphing. Do only real answers. So how do you fix this? Yeah, but you can fix it here. Go here and make it A plus BI form. Now, there's 2 ways to deal with this. You could use an if statement in the program. If the discriminant is negative, do something different. We could do that. Maybe we should do that. How about we do that? All right, everyone go to mode, right? Is everyone in mode?
Yeah.
Make sure that it says real. If it doesn't, go down there and hit enter. Okay, so that if you run it for 1, 2, 2, you'll get an error. And we can deal with it in the program. If you hit 2 for go to, it tells you the error is in the square root. Because it doesn't know how to square root a negative number when we're in real mode. So make sure your mode has, your mode has real. Not anything else on this line, real. All right, so we're going to fix it. See, the deal with QUAD1 was to use if statements. So let's use an if statement. Okay, here we go. So go to Program, Edit, 4, and we'll do that if the discriminant, when does this work? When the discriminant is what? Positive or even 0, right? Okay, so we need an if statement that isolates that. If the discriminant is greater than or equal to 0, do this. Otherwise, do something different. All right, so how about we push this down? I'm going to say second delete is insert, enter, and do an if statement. Where do you think if is? Where am I going to find it? Program 1. Hey, there you go. All right, so let's do it. If D, alpha D, is greater than, second math is test greater than is 3. Well, actually, I should say greater than or equal to 0. Second test greater than or equal to is 4. Because you can square root 0, right? So if it's greater than or equal to 0, do that. Okay. And by the way, while we're at it, how about root 2? Let's do root 2 also. All right, so how are you going to do root 2? Right, program.
Oh, minus instead of plus.
Right, IO display what? What should I write? So alpha quote, alpha R, what is it, 2, second test to get an equal sign. It's still in this, like a string mode, okay? Alpha quote, comma, and you're going to type the exact same thing except for a subtraction here. All right, so open parentheses for the numerator, negative alpha b, make sure you're using this negative in front of the b, minus this minus after the b, it's different. All right, this is a unary operator. It only works on one number at a time, changes the sign of b. This is a binary operator. It takes two numbers to subtract, right? That's different. This is the one I want there. Okay? All right, so what is it? The square root of alpha d. Close the numerator. I close the squirt. I close the numerator, divided by, open parentheses, 2 alpha a. And that's it. Okay. All right. Now I have to tell BASIC what this if is controlling. It's controlling all of this, but I have to tell it where it ends. So program 7. The if clause is controlling only these two lines. That's what that end means. All right. Let's see how this works. You ready? All we did was we added an if line before the display, we added another display, and an end. That's all we did. Anyone not have any of this? Okay, we're good? All right, let's test that. All right, so again, 1, 2, negative 1 was real, irrational, unequal. Oh, problem, wait, number 2. Oh, it doesn't like the end there, does it? All right, wait, I think I might need an end if I have an else. I guess I don't need the end. I take that back. All right, so delete that. Yeah, I'm thinking you need... Oh, wait, I need a then. Oh, is that what it is? I'm sorry. All right, go here. Second insert, and second delete is insert, and put a then there. I'm sorry, I forgot about that. Program, then. So if the discriminant is greater than or equal to 0, then do that. And then you do need the end, don't you? I'm going to put that back. Problem 7, right? Try that again. All right, so there's the whole if statement. So remember, QUAD1, QUAD2 is all about using if statements. This is good. Okay? Remember, Area 1, Area 2 is all about using lists and loops, right? Okay, let's quit that. Try it again. 1, 2, negative 1. There you go. Real, irrational, unequal. There they are. Perfect. All right, enter that. Enter again to run it again. 1, 2, 0 was real, rational, unequal. 0, negative 2, that's correct. Did you get that? If you plugged in 1, 2, 0? Who didn't get that? Okay, we're good? Okay, good. How about 1, 2, 1 was real, rational, equal? You should get the same root twice. Did you? Negative 1, is that right? Okay, now be careful. What if I put it in the complex case? What's going to happen?
You're going to get imaginary.
You're going to get nothing. Why? Because we didn't tell it to do anything. Look, if you edit QUAD1, it says if the discriminant is greater than or equal to 0, print stuff. But if the discriminant is less than 0, it's not going to do anything. Oh. So let's fix it. Are you ready? Here we go. We're here. This is how you're going to fix it. You need an else. If it's greater than or equal to 0, do the real stuff. Else, do the complex stuff. Where's else? Where do I get else? Program 3, right? 3? Okay. Now here you got to be careful. What are you going to display? You're going to display the real part, which is negative b over 2a, and the imaginary part, which is the square root of d over 2a. But it can't do the square root of d because it's negative. So change the sign. Make it negative d. All right, this is what I'm going to write. Ready? It's going to be a lot on my display line, so I'm not even going to label it root 1, root 2. I'm just going to write the roots. Ready? This is what you're going to do. Program IO display. Negative alpha b divided by parentheses 2 alpha a. That's the real part. Okay? Comma, alpha quote. How am I going to write this? Let's see. Plus, alpha quote, comma. Now here's the imaginary part. Are you ready? The square root of the opposite of alpha d, because I want to take the square root of a positive number, right? Divided by parentheses 2 alpha a, and then, comma, alpha quote I. Where's alpha I? Alpha quote. What does that do? You see what that does? Here, let me show you. On the smart boards, YouTube, I'm going to the smart board. Hang on. Okay. That's not good. All right. So when you say you're solving you're solving ax squared plus bx plus c equals 0, you get x equals negative b plus or minus the square root of b squared minus 4ac. That. Where's my a? All over 2a. I could write it like this. This is over 2a, and this is over 2a. Why am I making a big deal about that?
It's like the whole numerator.
Yeah, isn't that still, when you add two fractions to the same denominator, you're going to get the 2a on the bottom, right? But this is the thing. What if you square root in a negative? Then don't you factor out the I? So if this b squared minus 4ac thing is negative, you're going to have an I there. Right? How do you get the program to do that? I'm going to tell it to print this is the real part, quote, plus, this is the imaginary part, but change the sign so you can squirt it. Right, remember squirt? Okay. And then, comma, quote, put the I there myself. If you're in real mode, remember we changed the mode to real. That's the only way we can do this. And a lot of calculators you have to do that. That's why I'm sticking to real mode. Because Ziggy, the TI83, can do this in complex mode. A plus B I form, it can do this. But I'm pretending it can't because there's a lot of calculators that can't. Let's see if we can write this in basic you can. So I'm thinking standard basic how you do this, okay? So that's what I'm doing. I'm going to break this up as the real part, quote this. This part is the imaginary part. We're going to change the sign of the discriminant before it's square rooted so it's not negative anymore. And then quote this. That's what I'm doing. Okay? So does that work? That's actually root 1. But since I had to type so much stuff there, I didn't label it root 1 or root 2. I'm just spitting it out. Okay? So let's see if that works. Just that much. And I think I need an end now. So program end. All right, let's see what happens. Now remember, real irrational unequal, real rational unequal, and real rational equal all worked. What didn't work was 1, 2, 2 complex conjugate. So let's run it again for that. 1, 2, 2. Oh, go 2. What happened? Why does... Oh, I put it in the wrong... I didn't hit enter. Oh, I didn't hit enter on that line. Ow. Oh, dang it. Okay. Program, IO, display. Dang it. Okay. Negative alpha b divided by the quantity 2 alpha a. Okay. Comma. Alpha, quote, plus alpha, quote, comma. Okay, then the squirt of the opposite alpha d, because if I'm in the else clause, d is negative, divided by the quantity 2 alpha A, then comma, quote, I, and that's it. Now hit enter, darn it. There you go. Now put the end. Okay, let's test that. So 1, 2, and 2. You see what it did? -1 plus 1i. It looks weird, but there you go. Now, but that's the complete answer. -1 plus 1i. There's a way to make it print all in one line, but I forget how to do that. All right, now, do you need, let's see, program, what's missing? Isn't it supposed to be a second root?
Yeah, that would just be a negative.
Right, so how about, okay,
Plus minus, instead.
there you go. Program edit 4. I could write a whole other display line
I say plus minus.
down here, another display line that has the minus, but how about we just say, okay, plus or minus right here. How about I'll put a slash, in other words, divide. Oh wait, second insert, alpha quote. Okay. Do a second insert so it doesn't type over what you have. And a minus. So it's got this weird symbol, plus, slash, minus in quotes. It'll just print that out for me. All right, does everyone have this now? Else display the real part, which is negative b over 2a, comma, quotes, in quotes, plus or minus, comma, the imaginary part, which is the discriminant of the opposite, the square root of the opposite of the discriminant, all over 2a, comma, quote, the I, right? Let's see if that works. No.
Yes, we got it.
You got it? Wait, bottom. Okay? We're good? All right. So testing, can I get out of here? Okay. All right, so enter to reinterpret the whole program. 1, 2, 2, and there it is. -1 plus or minus 1i. So you can enter whatever the heck you want. Enter. 2, 3, 5. That happened to be complex. Look at it. -3/4 plus or minus 1.3919i. You can enter whatever the heck you want. 5, 3, 1. Right? These now a lot of these are complex. Look at that. -0.3 plus or minus 0.3317i. And it's running off to 4 places because I have fixed 4. If you want to do that, you can set it to round off for you. So who's stuck? Program edit 4. Bottom. Okay, coming around. Okay, who else is stuck? Anybody? All right, that's quad 1. Done. No, not done? Okay.
That's just quad 1. That's just quad 1. Boy, can we do this again? That means we got it.
Now go to parts. Tell me where it is.
Say it right now.
Try 1, 2, 3.
Say it right now. Say it. I'm not gonna hurt yourself.
right, so what's quad 2? Quad 2 prints out words, not numbers. Okay? Quad 2 prints out the nature of the roots. Is it real or not? Is it rational or not? Are they equal or not? Okay? So let's do quad 2. Here we go. And you're going to need a lot of if statements for this. Okay, program, wait, let me quit this. Program new, quad 2. Okay, so where's Q? I always forget. OPQ, there it is. No, that's O. OPQ. And U. I can never find it. U. A, D, and then hit alpha to get out of it to write the 2, and there you go. All right, you got quad 2? Okay, first thing we write is, what's the first thing we usually write? Your name, right? Quote, your name. Alpha M, alpha R. In case we're going to print it, alpha G. Okay, then we usually do what? Clear home. So program IO 8. Then we're still going to ask the user for A, B, and C. So how do you do that? Prompt, program, IO, prompt, alpha A, comma, alpha B. Wow, that was quick. Farthest one, huh?
Yeah, the nearest one didn't work.
It didn't work anyways.
Yeah,
All right. Now, notice, the first question. We're going to ask a bunch of questions. The first question, is it real or not? How do you know?
Positive, negative.
If what's positive or negative? D. So we still got to figure out D, right? All right, so let's do that. Alpha B squared minus 4 alpha A times alpha C stores as alpha D. Okay, so how do we ask a question? How do we ask the question? How do we know if it's positive or negative?
If D is greater than.
If, right. Program 1, if alpha D, you want greater than or equal to? Less than is complex. Greater than or equal to is real, right? So second test greater than or equal to is 4. Then, don't forget the then I did last time. Program